Hi, I'm Tom and I talk about code. Welcome to another live stream where I'm working on my compiler for my own programming language targeting my own virtual machine in Rust. Today we're going to try and do inline assembly because that's going to open a lot of doors for us. That's going to mean we can kind of hack around a few things the language can't do and then fill those in once I actually support them. I'm going to try, because I have this cool assembly preprocessor from when I was building this stuff, as a standalone assembler, I'm going to try and see if I can share symbols from the compiler into the assembler, but that's not a top priority. That's like a stretch goal. And then if we have time, I want to see if we can do some global constants, because I was playing around with a virtual screen again yesterday, some more virtual hardware, and being able to have a globally defined constant for like the offset of the screen, like where it kind of gets memory mapped in, the pixel display buffer, that would be cool. That would be cool. All right, so let's do some coding. Let's do some coding. That's not what I want. I want to start recording. Now, last stream as well, I was kind of hitting some errors with my break and continue loops. That was the last thing we built. And kind of a funny story about this. So I wrote some tests. Let's actually go into a directory. How about that? Let's go into some tests. I wrote some tests to see how these go, and it looks like my nested, like breaking out of a nested loop was broken, and then I looked more carefully at my test and I realized I was returning the wrong variable at the end, and now I think it all just works. Yeah, so that was funny. So that was gonna be the theme of today's stream, but then I like fixed it in 5 minutes before I went live, and that wasn't good. Well, it was good. It means we can do something new, which is fun, which is exciting. Which means we're gonna have to add new syntax to our AST. New syntax to the language. Bobbius, yeah, just a couple of comments about some AI stuff we were looking at before I officially started the stream, and yeah, making good reward functions for AI is really hard. I tried with a friend to enter a competition where you kind of had to make a trading strategy for a battery, and we I don't know if we came last, but we came pretty much last. It was pretty gross. Okay, so inline assembly, this is my idea. Let me show you the syntax first before we build it. So my idea is to define it like a function, except you say ASM with an exclamation mark to show that it's kind of like special. ASM, you'll have a label name, say foo bar, and then you can give it an argument list. So int A, int B, and then you give it a body. These are just, normal assembly lines like I've been writing this whole time. You might say, except A and B, A and B are passed in according to the calling convention, so they're in argument slots. So you would have to say load, stack, offset. You would say ASP1, or like whatever these args are. I would have to double check. Arg load stack offset plus 3. Yeah, okay, so this would be 3, this would be 4. We could load the A and B into registers and then do stuff with them, and like add A B, A equals A plus B. We can do stuff. This would be a kind of cool syntax. I think this would be useful, and then anything in the A register at the end is returned. They don't have an explicit return value. Every function is assumed to return something in the A register. So after a function's called, either you read the return value out of the A register or you assume it's been clobbered. There's no functions that don't return something. They're all assumed to clobber the A register. So so for example, this would add two numbers together, right? Because you're returning in the A register. I think this is a cool syntax. The question that I have is, say I wanted to do a jump. I wanted to set the PC to some immediate value. Could I jump to main? Because I have this assembly preprocessor that resolves labels like this. Could I hook the symbols I have from the compiler into this evaluator, right? That would be really cool. The other thing is, I don't know. Like you can't do labels, obviously, because you can't do any kind of function relative absolute function. Yeah, you can't do an absolute jump within a function. You can't say foo. You can't do this because it doesn't know where this assembly is being placed until the last stage of the compiler. So I don't know. I don't know if I can actually stop it doing that. There's a couple of footguns here, but we're gonna try and write this. What's cool is we're basically gonna say parse the header, and then it's just basically gonna be free text within the curly braces, and we're gonna let a later pass of the compiler work this out. That's the goal. That's the goal. Okay, so we're gonna get rid of that, or are we? I mean, maybe it's a good idea to, like, you know, let int a equal 0, let int b equal foo bar. You know, kind of have this test case where you would expect a to be 9 because you're adding 2 to 7. A couple of comments here. You can do a fix up run at the end of the compilation process, resolve any labels in the ASM. Well, you can, but I'm not outputting ASM, right? I'm outputting bytes. I'm not writing a bunch of text which then goes through an assembler. I'm doing it a level lower than that, right? I'm not invoking an assembler on the output of this because I want it to, I basically am doing this. I basically do a resolution pass at the end, but it doesn't work on assembly directly. Because, you know, if like I'm outputting in my code gen, the main thing I output is this unresolved instruction, which encapsulates this concept. It's either an instruction or it's a thing with a symbol. So I could parse my assembly into this, but this doesn't exist. I don't have a parser for this. I do have a parser in my assembler. Well, I actually don't have a parser in my assembler either. I have a preprocessor which kind of does this already. And it has the concept of a processed line part, which, yeah, is a thing that can have unresolved things in it. This is a different kind of abstraction, I guess, to the one I use in the compiler, which is a bit hard. And so I'm probably going to have these two things fight each other, but I can pre-process, then output this, then, like, this works in a texty world. So basically what I'm kind of saying, and I feel like I've done a lot of talking and not a lot of coding here, but basically what I'm saying is treat this as text, and then take the output as text, then parse it into instructions and make it the body of a function the same as you do when you actually compile real code, but just encapsulate that texty processing part to assembly and don't let it leak out into other things. That's what I'm going to try. That's the theory. So inline assembly is going to be a lot like a function definition. It's going to have an identifier. It's not going to have a return type, but it is going to have args, which is going to be this pair identifier type. And then it's going to have body, and body is just going to be a string. Okay, we don't, or maybe a vec of string, I guess, like just a series of lines. What does the preprocessor take? Build parts, what does it take? Resolve, yeah, so resolve, it just takes a string. So we're going to make this just a string. Excellent. Now we need to write a formatter for it. Inline. And I like to write these formatters first. Because it kind of informs how I'm going to parse it. Like, it's kind of working backwards, and I think that's a cool way to approach it. I think that's a really cool way to approach it. God, my hands are freezing today. So we're basically going to copy and paste this, right? It's basically the same thing. The body is just simpler. Here we just say body. Cool. Okay, so that's good. So, oh wait, hold on. No, I missed something. Return type. We don't have this anymore. So we just go straight to the name. We say ASM. Awesome. This is good. So now if I build this, what happens? It's going to yell at me about some stuff. Indentifier. Typing is really hard when your hands are this cold. Okay, so now there's a couple of places where I'm not dealing with this. Code gen. Cool. So if we have an inline assembly block, at top, Fit Rider, welcome. How's it going? I don't think I've seen you in a live chat for a while. So yeah, hope you're doing well. Thanks for stopping by. Now, this is where we just do... So this is actually... We ignore the body here, right? This is the first pass. Then we have a second pass where we actually do the compilation. In the first pass, we just care about definitions. We just care about the function signatures to make the functions available to other functions. This gets around having to have, like, you know, headers that forward declare functions like in C. That's my goal. This does mean that you can't really like link against something else, but that's also fine. We're a small scope function. We're not. You don't have a library, right? You just dump all your code you're using in. Hoisting? Is this called function hoisting? I just always call it kind of like 2pass, right? You're implementing better error handling. How are you implementing better error handling? Like line numbers and kind of user experience, or as in it doesn't just die, like it tries to recover from things without them all being fatal errors. So it turns out that an inline assembly block is the same as a function definition, except the return type is just going to be where is this function definition that's in context? AST type. So this is going to be an AST type. Every inline assembly function returns an int, right? Because it just returns a word in the A register. That's it. That's all we do. Cool. Recoverable error handling, hoisting the function definitions to the top level scope. Yeah, okay, that makes sense. And again, you know, maybe thinking about namespacing and stuff would be good at some point, but I feel like that's language too. Like, I feel like it would be good to write a smarter language in this language. I want this to be self-hosted on the machine sooner rather than later, but also this is a language for writing small programs because the machine is small. Recoverable error handling, try to jump to the next statement as soon as you hit an error. Hit the next, find the next. Is that actually what you want, right? You've got to think about error handling. What state do you leave everything in? If you just keep going, are you going to leave things broken and kind of propagate errors out, right? A broken thing begets another broken thing, and then everything's broken. So this is good. This works. And now we just need to do the same thing, kind of thing here. Top level, inline ASM. Now we need the name and the body, but we actually don't care about the args. So, register labels. So we don't have to worry about any of this. We don't have to worry about the labels. We don't have to worry about... helpful to do that when writing something you plan to make a language server for. That's interesting. So that it can keep going, basically. That's cool. Because yeah, I guess you don't want one error to stop the world. That makes sense. Okay, so lots of this stuff, block size matters. We need to know how many. We need to know how big this thing is. Let's just try and invoke a preprocessor. So pp. And I think we just make a default one. Yeah, variables. So this is where we would try and map our symbols into this, and they map to a string, which is a little bit janky. Anyway, so let's say we'll make a preprocessor, and then we'll say pp.resolve. Is it resolve? It is resolve. It gives us back a list of processed lines, and processed lines can be turned into a string. Yes. They also have a source line number, which is really cool for mapping out errors. Interpreter runtime errors, you stop when you hit one. Yeah, cool. That makes sense. That makes sense. Are you following along with anything for your interpreter? Are you doing like the Nystrom book or anything like that? Or are you doing what I'm doing and just winging it? Because winging it's pretty fun. Winging it's pretty fun. So we get a list of process lines, then we can combine that into, well, and then we can assemble each of those lines. We can use, there's a function called assemble line. If we look at the assembler, it preprocessor resolve, it maps the errors, then for each line, okay, it does another pass. It would be nice if this was all wrapped up a little bit more, maybe. And then, yeah, it assembles it. It uses my encoding stuff. Cool. Okay, well, let's try and copy this. So code gen, so let lines equal resolve, body, map error, and what's the error? So it's a preprocessor error. So compile error, we want to make an error specifically for this. We'll say inline ASM error, and this will just take a string. Except we don't need the word error in an error type. This is one of my pet peeves, right? Don't call it X error, just call it X. It's already in type called something error. Finding it hard to find a decent book for use case. It's either something you know or something too theoretical, bad at following through books. Yeah, I tend to find that as well, actually. It's something that frustrates me a bit, where you're trying to follow something through and then it goes off on a rabbit hole that doesn't feel relevant, and it can be frustrating. But usually those things are there for a reason. Right? That's what I kind of find. I find when I persist, those things are usually rewarding, even if it feels like I don't know what the fuck's going on at the time. All right, so we get the lines, and then we're gonna say lines.iter.map x pp.resolve2. This has a really stupid name. Resolve pass 2. Except this returns an error. There's a way you can collect this, right? You can turn a vec of result into a result of vec, I think. Also, I can do this without the explicit thing. Let's see if this works, right? So can I collect this into a vec of result? Vec of result. Vec of result string preprocessor error, right? I think, oh no, hold on, I did that backwards. I want to collect it into a result of vec string preprocessor error. I think this is okay. I think this is valid. Bobbius coming in with the, let me copy that link so I can open it in the right browser. The clutch Stack Overflow. All right. This is a good comment. Blah blah blah. Into iter, yeah, you can just collect it. Okay, this is good. So lines as a string, and then I need to map again. Actually, let's just copy and paste the map from here. What font am I using? I think this is Deja Vu Sans. It's Deja Vu Sans. Someone asked me this the other day and I had to check. So inline ASM, now we say for, let's, instruction, we can parse an instruction. Okay, so let register, so what do we do? Block is compile body. What do we do with block? Block instructions, blah, 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 that's fine. Define, block local count, functions push block. Context, list of functions, it's a vec of block. So block, a block is a list of instructions and an offset. So for this, we can make a block out of this, right? There's nothing functioning about a block. An inline assembly directive becomes a block with no locals. That's it. That's all it is. So let's say let out, make the default empty block. I think that's fine. It implements default, so that is okay. And lines stir. So for each line, we want to say we want to parse it, right? Instruction. Where do we? Yeah, instruction from stir. Cool. This is pretty good. This is pretty good. Yeah, instruction. This is actually a nice framework to start from. So instruction from stir. So every, I don't have this, I'm sorry. I can link it on GitHub in a bit. I can do it manually. I am Nightbot. So for every instruction, we try and parse the instruction from a string. This toString is automatically generated from all of the macros when I define my ops. This derive macro does all of my encoding and decoding stuff. So we try and pull an instruction out, and we stop short of this. We don't actually do this here. And we also need to not panic, but we'll get to that in a second. So if we have an instruction, all we do is we say the block.instructions.push, and we're just going to push an unresolved instruction. This is far too many instances of the word instruction on one line, but an unresolved instruction is essentially an instruction type that can be a thing with fields that need resolving, with symbols that need resolving, or it can just be an instruction. So an unresolved instruction can just be an instruction. And in this case, it is just an instruction. It's the instruction. And that's all we need to do. That's all we need to do. For some reason, there's a lot of white space at the end of this line. Okay, cool. Now, if we fail, instead of this, let's return. Yeah, we return an error, compile, error, inline ASM. Because inline ASM contains something that's not a valid instruction, we're gonna return, let's do format. Let's do format. That's kind of, it's a shame. When we do this mapping, we actually lose some line information from here, but that's okay. That is okay. Okay, so we just want to say fail to parse instruction line S. That was not enough parentheses. All right, cool. So instead of panicking, we do that, which is nice. And then here we want to do the same thing, but we say failed to cool. So if there's more information, we want to pass it on, otherwise we just die. And this doesn't need to be wrapped up in curly braces. Get rid of this panic. Put this, I guess that doesn't matter so much to drop onto a new line. This one's more important to drop onto a new line. Cool. Unix racing repo isn't up to date. It is pretty up to date. Oh, actually, do you know what it is? It's that this terminal, I normally use ST. I normally use, I normally use this terminal. that looks like this, but for streaming I use one that's just easy. I use Alacrity, and my Alacrity dot files aren't there. Let me show you my Alacrity dot files real quick. All right. Yeah, I haven't changed much in the last 3 years, to be honest. I have found settings that work, and I just do that. Config alacrity.toml. This is my Alacrity config. Like, my dot files are pretty minimal. They're pretty minimal. I like to keep things pretty vanilla. I was having this chat with someone the other day, right? I like keeping things pretty minimal. Like, I don't have LSP. I don't use LSP for any... I have it set up for JavaScript, and I don't enjoy it. But, you know, just keep it simple. Keep it minimal. I can go to any computer with Vim, and I'm ready to go. Okay, so we have built a block. Let's maybe call this block. That's a better name. Block. We have built a block. Is this inline? God, this doesn't look like it's lined up to me for some reason. Okay, so we've got a block. The only thing missing is the offset of the block. So we need to, and we can do this. We can do this. Block size, block register, program offset. So block.offset equals program offset. And then we need to do this as well. We make the block size, we push the block, and then we increase the program offset. The program offset is where the next block will start. So we're putting it at the current program offset, not program offset. We calculate the size of the block. Local count args. We calculate the size of the block, we update the offset by that much, then we add this block. Now, where are the args? Where do we put args? Compile body. Block. I feel like the block does not have args. I feel like block.args isn't really used. Oh, it's here. Why is this done here? This feels a bit backwards, right? This feels a little ass backwards. It feels like we can populate this before we actually call compile body. Like, maybe this just needs to get pulled out, right? Because not only that, but we actually don't need to even do the lookup. We don't even need to do the lookup. Look, I'm gonna keep it here for now, but I'm also just gonna say, like, hey, to do copy this for function defs rather than lookup in compile body. Okay, so rather than doing this, right? Rather than doing all this, we can just use the args that are part of the block, that are part of the definition. Define arg. Not that this is ever used, but let's do this just because it's fun. Block offset, instructions insert, push, excellent. And now when I build this, it's going to work first time, obviously. Top level with a lowercase l, that was a fun one. Okay, so preprocessor, we want to use, now, use create popmod. Okay, so we want to use simple VM preprocessor, and then we want to grab preprocessor from that. Cool. Instruction parse error. This comes from instruction, so we need to grab instruction parse error as well. Resolve body. This needs to be a ref. What else have we got? What else have we got? Compiler error, I think. I'm cutting off some of this here, but that's okay. That's okay. Oh, how's everyone doing? How's everyone finding method not a field? How is everyone's Tuesday going? It's a slow Tuesday here today. I got a singing lesson in like, I don't know, 2 hours, so I need to think about that. But otherwise, yeah, just a good day for some code. Instruction from stir. I need to import std from stir. This one catches me out. Having to use the trait to actually use the trait catches me off guard. Still Monday. Wow, I always forget how far in the past some people are. I guess if you're in America, right? So if you're in Europe, because I'm 11 hours ahead, so if you're in Europe, like if you're in London, it's only just gone Tuesday. Today's a holiday. What holiday is it today? What's the holiday? Canada Day. That's cool. That's cool. Yeah, it sounds like a good celebration. 338. Nice. So we've got 2 Canadians. That's fun. No, oops. I didn't actually read what that said. Identifier new. Oops. Identifier. Wait, what is this one again? Sorry, block. No, it just wants a stir. It just wants a stir. So it's this. Really helps if you actually read what you're doing. Name is not used here, so let's get rid of name. What else was there? Block needs to be mutable. Let's save this, then build. We're getting close. We're honing in. What does Canada Day celebrate? Like, what's the relevance of the actual date? Is it the date something happened? All right, beautiful, beautiful. Let's head over and add this to the parser. Function definition. So this is going to be a lot like a function definition. It's going to be a lot like a function definition. Inline ASM. I guess inline maybe isn't the best word. This is like an ASM block. Canadian Confederation. There you go. So the day you got rid of the Brits. Wait, is that what Confederation means? Yeah, when you became like your own federal entity, not just part of 3 colonies. Yeah, it became a country rather than just a bunch of UK territories, colonies. Yeah, no, like Australia is still Commonwealth as well, right? But where apart from the Governor General, there's not much that really, like, you know, the Queen or King, I guess, doesn't really have a say in anything going on. Okay, so instead of return type, we're gonna now skip white space. We're gonna get a token, and that token is gonna be just the magic word ASM. Still got the Queen's photo on your money. Yeah. I mean, Australia has the Queen's head on coins. I could show you an Australian coin. Wait, maybe I can. Hold on. I don't know how well this will show up, but yeah, here's a 20-cent piece. I don't know why I have actual money. There's Liz. But I like the 20-cent piece because on the other side... On the other side we have a platypus. And that's a pretty cool animal. But yeah, like Governor General. Apart from that one time our Governor General got rid of a PM, yikes. It's been fine otherwise. That only caused a small constitutional crisis. Cool. Cool. So we get the name, we get the args, and now we just want to get the body. And the body is going to be anything wrapped in. So, okay, so repeat 1. So this is going to be... The important thing here is that we tell it any character except a closing brace. Anything... So repeat not car. Anything that is not an opening or a closing brace. Anything that's not one of these 2 characters, right? Cool. And now what we get back out of this is an inline ASM. which has a name, a body, and args. Okay, so what happens if I build this? Expected string found vec car. Vec car join. So can I do that? Can I do that? Can I join it into a string? Sorry, body. Join car. Rust vec car to string. Maybe I can just call toString, or probably collect, right? This is probably, yeah, fucking, it's always collect. How does this magical function do everything that I need it to do? How does this work? It's phenomenal. So body.iter.collect. Look at that, man. It's magic. It's magic. It just knows what to do. Okay, so function definition, inline, ASM. So either of these things. Do we do function definition or inline ASM first? Doesn't matter. I think we should do inline ASM first. I think. Because no. We should do inline ASM first. We should try and do things that are more flexible. Collect is magic. It's seriously, it's magic. It's magic. Okay, so build this. Let's make a test. Let's go back to our test compiler, and let's copy and paste. This file is getting way too long, but that's okay. I'll break it up eventually. Let's say inline ASM. We'll have a main function. We'll basically do the test that I wrote out before, okay? So return ASM will have a function called add nums, int a, int b, and we'll just do the simplest possible thing. We're gonna say what I did before. So load stack offset a sp3 sp4 oops bsp4, and then we just add a b and we store the result in a, and that is all she wrote. Now, I think I've missed something, but we'll find out very shortly. Add nums a8. Let's make them more distinct numbers. So we would expect this to be 7 plus 11, that is 18. And when I test this, it's probably going to blow up for a really unexpected reason. Yeah, parse error. Of course it's a parse error. It's always a parse error. It's always a freaking parse error. Expected token ASM. What context is this part of? These are so hard to read. God, I made this better. You can kind of get through it. So when we're parsing this whole block, something's gone wrong. Errors, parse error, context. Let int b equals add nums. Add nums. So it looks like the issue expected token. Okay, so it looks like the issue is here, which is kind of weird. Make test. Is this gonna yell at me? Okay, this still yells at me. Okay, so we're gonna have to go and actually write a real parser test for this. We're gonna do this thing, where we wrap it all in a little block so we can do lots of tests next to each other. Expected, we're gonna say ASM foobar int a, int b, and then we're gonna have add a, b, a, sub a, b, a. Cool, expected, run parser, inline ASM. Let's see what happens here. Test inline. So this fails here because I missed a new line. Is that it? I missed 2 new lines. Test inline ASM. New line. Now I have 1 too many new lines. What the hell? Hold on. Wait. So it's adding, right? When it formats it, it adds an extra new line that it shouldn't. This is actually really fixable. This is really fixable. Display for top level. I think we just do this, right? Yeah, now everything fails except everything passes except this. Test inline ASM, so it parses okay. So that's good news. That's good news. Now, it appears to blow up because something. What's blown up here? What's wrong? What's wrong? Errors, parse error, context. So here, what's the error? The error is... I see what happened. I see what's happened. Here's a funny thing. Ready to watch this test fail? Okay, so it turns out that underscores are not valid characters for identifiers. We should probably fix this. Where do I... Identifier. Repeat alphanumeric. See, I want alphanumeric or with underscore, basically. That's my identifier. Let's make it to do. To do. And we will just accept that we can't use underscores in names for now. Okay, that's very funny. That's very funny. Now this fails for predictable reasons. That's good. Add nums A11. Okay, now we're making progress. We don't know the symbol add nums. It's not getting defined properly. And that's good because we know where to look for this. We know to look in CodeGen. Because it should be getting defined, right? There's a function definition for it. So why do we not get defined? Why do we not find it? Unknown symbol. Compiler 323. That's not the right place, is it? Length test. Oh no, sorry, that's in the test. So it would be good. It would be good. Is there something I've missed? Oh, this is probably... No, that's the local count that we define. That's okay, because we don't... That's just not relevant anywhere. That's okay, that's okay. Inline ASM. Weird. Functions push. So we definitely define it. We definitely define it up here. Function defs insert. Function definition args. Return type. Yeah. That's annoying. That's really annoying. Why would this be going wrong? So one thing that would be useful would be to know where this is actually being called from, right? Like what part of our program is even doing this? So what are we compiling right now? How do we do this? So maybe here, right? Maybe in here. So it's when we resolve. That's really hard to deal with. That's really hard to deal with. It's just weird. Compile res. Let's just dump out the whole context because that's been useful in the past. Symbols, main, functions, instructions, blah, 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 blah. Block. Offset local count args. So the function gets defined, return type int, we've got 2 args, and the name. I really need some pretty printing for this. Yeah, I do. I really do. I need an actual... You know what? Let's actually do that. That won't be hard to do. Impl. Let's just copy and paste this signature because I can never remember what it is. Let's just pretty print a context real quick, or you know, stringify it, like display it. That would be nice. So, right. What do I? I don't know if display is the right thing here, but maybe this is okay. So we write this, then we say for. Let's write all the symbols. We'll say self.symbols.iter.map. We're gonna map them into something nice and stringy. Let's say format. Actually, is this kv? K equals v, and then we join with a comma space. And we need to deal with the errors here as well. Cool. Okay, so now for each function definition, I think this is all we need. We don't need to care about the actual body necessarily right now. And a function definition, yeah, again. A function definition, we just say self function defs.iter.map. We're going to do exactly the same thing, really. Except we're going to have to split these onto different lines because this is going to get long. Iter map. Okay. So we're going to nest this thing where we're going to say v.args v.return type, and then we'll say v.args.iter.map. We'll just get the name for now. That's all that we really care about. Join. Okay, here we go. So we map that, and then again we join it with a thing. My god. But I think that might be it. I think that might do it. That might do it. For self.function defs, and probably as a ref. Oh, oops, we can't use f because that's already used. Let's call it func f. Oops, what am I doing? Func.iter.map, blah, 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 blah. There we go, that makes more sense. Except... What am I doing? But I forgot what I was doing. Hold on. I split the difference between two different things here. Okay, so for func def and function definitions, the reason that I started writing this with this loop was so that I didn't have to do this weird nested thing, and then I wrote it anyway because I forgot what I was doing. So we're gonna write, it's gonna be func this thing. Yeah, so this is the thing. And actually, I think right, I don't think I need the format within the right. I think I just do this. My god, yeah, I made that much more complicated for myself than it needed to be. But that's good, that was good practice. There we go, that makes more sense now. Local variable with the same name. Oh yeah, so it's not v anymore, it's def. No join found for map. So I have to collect this before I can join it, which is annoying. It's an annoying amount of typing, but that's just life. We're gonna split this out nicer, just so that it doesn't look quite as crazy. That makes more sense. Okay, there we go, there we go. This is turning into be a rabbit hole in and of itself. Join is not satisfied. Join. Result. String join, mismatch types. Oh yeah, well this just needs to say, actually we can just do that. Why can't we join? I'm definitely doing it somewhere. So in the main binary I'm doing it. Main 38, I've got a dot join. This is a vec. Why can't I join a vec? What's going on here? This definitely args iter. Okay, what if I turn this into string? Cannot be. Oh, you can't undo it. Oh, well actually it's because of this. I need to say to owned. There we go. There we go. Result must be used. We just put a question mark here. Now we've got this. Now when I go back into my tests, I can just print out the context in a human readable way. Symbols. Cool, this looks a little better. Main. Except I want new lines in between these things. That's a lot better. That's a lot better. That was worth doing. This is human readable now. This is human readable now. Okay, so we can immediately see the problem. We can immediately see the problem. Main is defined as a symbol, but addnums is not. And I can immediately see why this has happened, because the actual location of this comes from compile body. Now, compile body actually does a few important things other than just compiling the body. It gives us a header, and I think it also does the return. Load previous, yeah, it also does the function return. So we need to copy and paste this into our ASM. We sadly do. Or, ooh, here's a funny thought. Here's a funny thought. What if we just don't, what if we just give it no statements to compile, right? What if we, is that gonna work? I can't sim. unfortunately, this thing is gonna break. Okay, we're gonna do the dumb copy and paste thing for now. So where we do our inline assembly, before we add this, so when we make our block, the first thing that this block needs to have is a label. Block instructions push, it needs to have a label, and this label is what gets resolved into the actual location of the function at compile time. This is maybe suboptimal, but it means it'll be easier. It makes some things easier. I guess the other thing we could do, like maybe we don't actually need to do this, we could just define a symbol in the context, right? Because when we resolve, all this does when we resolve it, oh actually sorry, no, when we define what do we do? Register labels, that's it. Register, that's in block. All it says is context defined. So if we do this, function offset plus offset within the function, but this is the offset within the function. If this is the first thing in the function, it's just 0. So instead of putting a label in that gets resolved, we can just define this directly. We can just define this straight out. It means we can't do recursion, but I think that's okay. So program offset. Oops. So we're gonna define block.offset, and this is gonna be the name of the function. So now we need to grab name back, and this takes a symbol, I think, rather than a string. So this is gonna yell at me. Expected a symbol. So symbol new name dot 0, and then it needs to be a ref. Sorry, that was wrong as well. This needs to be a ref. I definitely need to make some kind of, I need to make symbol and identifier into and from for each other. Okay, so that's good. So now if we make t, it fails, but for a different reason. 0 instruction. Yes. So this is good, right? Why do we get a 0 instruction for this test? Tests. Because it looks fine, right? Well, the problem is that this assembly function block, currently, once we finish executing this instruction, we fall through. Now, should inline assembly be in charge of returning? Probably not. That's too much responsibility to put inside every inline ASM block. Maybe we need some directive so we can say like, or you know, some way that we can annotate these if they're not supposed to be functions. But the way I'm thinking about this right now, I think it makes a lot more sense for them to behave like functions that we call. We're using stack arguments, which is great. So when we go back into CodeGen, this is where we're gonna have to copy and paste, because when we compile a body, which is different to a block, when we compile a body, we have this outro. So this has to go here somewhere. I guess here, right? We have to put this in. The block has to return. So we get the return address, we reset the stack pointer, we load the previous base pointer, we set up the program counter, and then we jump back to it. Excellent. Now when we test this, it's gonna work. And everything passes. It behaves exactly as we expect. That's very, very cool. I honestly was kind of surprised that worked first time. So we've got inline assembly. Holy crap, that's kind of insane. I can't believe that worked. That's going to be really useful when we start doing stuff with my virtual screen, right? Because right now, my code doesn't have the concept of a pointer, of a memory address, but we can hack around that by writing functions that manipulate assembly directly. So for example, when I'm working with my screen, I'll be able to say, make an assembly function called putPixel, which will take an X, a Y, and a color, and it'll do the stuff, right? We'll you know, we'll get an offset, which is going to be like y times width plus x, whatever, however this ends up working, you know, some... Right, whatever happens here. And then... Oh no, sorry, hold on. This is a function. We'll have a function called this, but then... So we'll work out an offset. And sorry, this needs to be an int as well. Oh my gosh, my cold hands. Offset. And then we'll say like write byte of... we'll say this, right? And then this will be an assembly block called write byte, but we need to support underscores first. Write byte, int adder, int value. And you know, this should probably be a byte or something eventually, but everything's a word right now because we're very C-like. It's all very simple. And then you would say, you know, load stack offset, load the address into the M register, load the value into the C register, and then store byte. Right? So we can do that. Now, eventually, it would be nice to be able to say, and then maybe say, you know, maybe even just really simplistically say address equals col, and treat like any number can just be treated as an address. Or maybe it should be like, you know, I haven't decided the exact syntax we're going to use yet. I don't know if I like the star. I don't know how I feel about the star, basically. Maybe it'll be something else. I don't know. I'm thinking about different syntax. I've got different ideas about different syntax, and I don't have a firm decision yet. But basically to be able to do something like this at some point. That would be cool. But the cool thing is, this is actually also just an int, right? Like an address to an integer is just an integer. An address to a t is just an integer. It's just a number because we're basically writing C. We've got C semantics. So this is kind of where I want to go eventually. And honestly, like addresses, this would be really useful to have. It would be useful to not have to hack around this. One of the first steps, I think, towards this is going to be the next thing I was thinking about. Let's just quickly check this off. What would a global const look like? How would we even do this? I suspect my brain is actually too fried to tackle this right now. I might need to go do some life stuff, unfortunately. So we will leave this as an exercise to the viewer. No, we will leave this as a mystery for another day. We did inline assembly, which is really, really cool, and it's going to open doors. It's definitely going to make bridging over features we don't have yet a lot simpler, as I kind of just showed. All right, so let's find a cool channel to raid. Thank you everyone who's been tuning in. Yesterday, I think we raided... Who did we raid? It was Lambda Calculus in Go. It was like a Portuguese guy. That was cool. Yeah, fun stream. Thank you. I had a lot of fun doing it, and I feel good about the fact that things are kind of working. What is a good channel? Working on a talk for a conference. That's kind of fun. Anything can happen. Universal chat client. That's kind of cool. I think I've rated that guy before. Good luck becoming a software engineer. Developing a Game Boy game. That's fun. A viewers game. Let's find someone fun to raid. Alright, let me jump into Twitch main, Twitch proper, and software, game dev. I want to find someone cool. But yeah, it's been a good stream. I'm glad we've got cool people hanging out, giving feedback. I'm enjoying it a lot. Pixel art and C++. Game dev, that sounds fun. Untitled broadcast. Windows released. It's hard. It's this line of like something interesting, but also probably someone that speaks English. It's always hard to find someone that sounds good. Maybe, I don't know, maybe where was that? Pixel art and C++ game dev. let's have a look at what's going on there. So this has been a lot of fun. This has been so much fun. Art. Let's throw some viewers over this way. It's been a fun stream. Thanks for tuning in. Thanks to everyone who continues to watch on YouTube. It's been a blast. It's been a blast. Let's do it. Let's head over and check this out. All right, I will see you guys next time. Bye.